I'd like to go over the answers to the 4.3 quick check. So the first one is dealing with acids and bases. What do we know about acids and bases? So something that tastes sour, okay, tastes sour, that is classic acid, and we did that when we gave out the sour candies. Okay, magnesium hydroxide, anything that ends in a hydroxide, we should know is a base, unless it's an alcohol, is corrosive. Corrosive, I would say that's an acid. Lye, that's a common name for sodium hydroxide. It's a drain cleaner. Okay, and that's definitely a base, NaOH. Neutralizes bases is an acid. NH3, that's one of the bases that we had to memorize. Remember, that's one where you had to mix it with water, and then it turns into ammonium and hydroxide, and that's where the hydroxides come from. Okay, turns cabbage juice red, that's acid. Increases the H plus concentration, that is acid, and that is the Arrhenius definition of an acid. Turns cabbage juice blue, okay, that's a base. H plus donor, okay, that is an acid, and that is the Bronsted-Lowry definition of an acid. So there are two different definitions for acids, theoretical definitions, Arrhenius and Bronsted-Lowry. Increases OH minus, that's a base, and that's the Arrhenius definition. Neutralizes acids, okay, bases neutralize acids. C2H3O2, that's acetic acid, that's an acid, and that's also the one that's vinegar. That's the acid that's in vinegar. Tastes bitter, bases taste bitter. H plus acceptor, that's a base, and again, that's the Bronsted-Lowry definition. And dissolved baking soda, we tested that, and that was a base. Okay, and again, that's the other base that doesn't look like a base. It's HCO3 minus. Okay, when you mix it with water, then it accepts an H plus, and it becomes H2CO3 and OH minus. So those are the answers, acids and bases, and it does pick out a couple little things you got to remember, so remember that NH3 is a base, HCO3 minus is a base, and those are two things that we tested. Remember that the acetic acid is vinegar, that's a weak acid, and that lye is sodium hydroxide. So those little tidbits you need to have in your brain as well. Okay, electrolytes. Okay, electrolytes, when we were testing things with the light bulb, okay, so we want to get strong electrolytes, weak electrolytes, and non-electrolytes. Okay, just as a quick review, strong electrolytes are going to be strong acids, okay, strong bases, and soluble solids. Those three things are going to be strong electrolytes. Okay, the weak electrolytes will be weak acids, okay, weak bases, and the insoluble solids, okay, because they're not totally insoluble, they break up a little bit. The non-electrolytes, those are going to be the things that are the covalent compounds, like sugar, okay, things like that. Okay, strong acid solution. Strong means a strong electrolyte. Okay, large numbers of ions, that's the idea. That's why strong electrolytes are strong, because they have lots of ions to conduct electricity. A weak base will be a weak electrolyte. A weak acid will be a weak electrolyte. That's a W. NaCl solution, that is definitely soluble. Okay, we know that salt dissolves, so that's a strong electrolyte. Now on a test, you would also have the chart you could look at, and if you looked at sodium this way and chloride that way, you can say, okay, that says aqueous. Okay, aqueous means it dissolves well, it's a strong electrolyte. Conducts electricity well, that's the definition of a strong electrolyte. Strong base solution, strong electrolyte. So if you see strong, you know it's a strong electrolyte. If you see weak, you know it's a weak electrolyte. Does not conduct electricity. Okay, that's the definition of a non-electrolyte. Vinegar, we tested that. You're supposed to remember that that was a weak electrolyte. And the fact that we actually put that on our food, we know that that's going to be a weak electrolyte. Not a non, maybe or a non, but in this case it's weak. Insoluble salt solution, okay, I'm going to call that a weak electrolyte. Okay, it breaks up a little bit. We do a double arrow, and we get a little bit of positive and a little bit of negative. That's supposed to be a plus. A little bit of positive and negative ions. No dissolved ions in solution, that's a non-electrolyte. Milk of magnesia, that was the white creamy stuff that we tested, and that was a weak electrolyte, weak base. And solution contains few ions, that's a weak electrolyte, but it does have some ions, so that's weak. And pool acid, that's hydrochloric acid. Okay, that's a very strong swimming pool acid, and that was definitely a strong electrolyte. Okay, dissociation equations. For each one of these, we need to decide whether it's strong or weak, whether it's an acid or a base, or whether it's a soluble or insoluble salt. And through this whole thing, then you're also going to have that chart, okay, to look at, and it has lists of strong acids and bases, so that'll be there for you on the test. Okay, write the equation that represents the dissociation. So in each of these cases, it's going to be the same idea. It's going to break up into its ions. Okay, so HNO3 is going to break up to give you H plus and NO3 minus. HF is going to give you H plus and F minus. Calcium hydroxide is going to give calcium 2 plus and 2 OH minuses. NH3, that's the one we have to remember that you put it with water, double arrow, and then you get NH4 plus and OH minus. And remember why is because there's an H that leaves here and goes over here, H plus, and you get NH4 plus and OH minus. Okay, PbI2, you're going to get Pb2 plus and 2 I minuses. And AlNO3 taken 3 times, you're going to get an Al3 plus and 3 NO3 minuses. So for each one of these, except for this one where you have to memorize, for each of them, just break up into the ions that you can see. Now the other part about this is, should you use a single arrow or double arrow? And that depends on which one you're doing here. So if it's a strong acid, strong base, or a soluble salt, those have single arrows, and the other 3 are going to have double arrows. And none of these will be non-electrolytes because they are going to dissociate. So HNO3, that's on our list of strong acids. You can see that on your strong acid list, so that is going to be a single arrow. HF is a weak, okay? It's a weak acid because when you look at your list, I mean, it's definitely acid because it starts with H, but it's not one of the strong acids, so we know it's weak. That means it breaks up and goes back together, and it's going to be mostly together. When we do double arrows, it means it's mostly together. It just breaks up a little. So weak acid. Okay, calcium hydroxide. Calcium hydroxide, when we look on our list, we're going to find out that's one of our few strong acids. So it's going to be our strong bases. We know it's a base because of hydroxide. Okay, ammonia, that's going to be a weak base. And like I said, that's why we have the double arrow here. You just memorize that one. Okay, lead iodide, you have to look at it and say, okay, lead iodide, if we go on our chart and we look at lead and we look at iodide, it's going to say solid. Okay, and that's because it does not dissolve very well at all. So it's going to be a double arrow. And again, it's mostly together. So we're going to call that insoluble solid. Okay, we're going to see that nitrates, when we start looking at nitrates on the list, every nitrate is always aqueous. Okay, nitrates are always aqueous. So it's a single arrow. It's going to totally break up into ions. So it's going to be a strong electrolyte, and that's going to be a soluble solid. So that's the way this quick check works.